Welcome. We're about to go on a journey through the entire history of front-end architecture. We're going to trace the path from those first, super simple web documents all the way to the complex, interactive apps that we all use every single day. Okay, let's really dig into this, because if you can get your head around this one idea, you're on your way to thinking like a senior engineer. See, it's not just about what you can build, it's about why you build it a certain way, and, just as important, what you're giving up in the process.
So here's our game plan. We'll start with that senior mindset. Then we'll walk through how the web evolved, from static pages to MVC, and then boom, the single-page app revolution. After that, we'll see how we solved all the new performance problems and tried to tame these massive code bases. And finally, we'll wrap it all up so you know exactly how to give that killer, senior-level answer when you're asked about architecture.
All right, so where did it all start? Well, before we had all these complex frameworks and build tools we have today, the web was it was a much simpler place. You could almost think of it like a giant global library of documents.
Yeah, the web started out super simple, super fast. Pages were basically just digital newspapers, you know? Text, images, not a whole lot of interaction. But people wanted more. They wanted dynamic, personalized content. And that demand sparked the very first major architectural shift, the Model View Controller Pattern, or MVC for short.
So frameworks like Ruby on Rails and Django, they really brought this pattern to the masses. The idea was that the server would grab data from a database, that's the model, use a controller to apply some business logic, and then it would literally build a custom HTML page, the view, and send that finished page down to the user's browser.
And this slide right here, it perfectly shows that core concept of trade-offs. MVC was great. It totally solved the problem of boring, static content. But it created new problems. Every single time you click something, you had to wait for a full page reload from the server. The performance wasn't amazing, and the front end and back end were just tightly coupled together.
So all those limitations of MVC really set the stage for the next big thing. JavaScript was getting more and more powerful, and a new idea started to take hold. What if we moved all that logic from the server and put it right into the client's browser? And just like that, with frameworks like React, Vue, and Angular, the single-page app, or SPA, was born. Now the application itself lived inside the user's browser. It handled stuff like validation and state, and it would just call out to an API when it needed data. Honestly, this is where the modern front-end engineer role really came to life. This created a huge split in philosophy, really. We went from what we call thin clients, where the browser was pretty dumb and just displayed whatever the server told it to these new thick clients, where the browser was running a whole powerful application with its own business logic.
And here we go again, back to our favorite topic, trade-offs. SPAs were a massive win for the user. We got these rich, app-like experiences. But of course, they created a brand new set of engineering headaches. Things like terrible SEO and painfully slow initial load times, all because the browser had to download this gigantic bundle of JavaScript before it could show the user anything at all.
So what do you think happened next? Well, naturally, the next phase of evolution was all about fixing these new problems. The big question was, how can we keep all that rich interactivity of an SPA, but fix the awful performance and SEO issues?
As our apps got bigger, they had to support more than just the web. We had mobile apps too. And a single, one-size-fits-all API just wasn't cutting it anymore. It got bloated. So the back-end for front-end, or BFF pattern, came along. The idea was to give each client its own special, tailored API, often built and owned by the front-end team itself.
Now, to fix that slow initial load, we kind of went back to the future with server-side rendering, or SSR. A server pre-builds the initial HTML, so the user sees content right away. But here's the catch. That page is just static. It's not interactive, not until the full JavaScript app downloads and hydrates it, which is a fancy way of saying it attaches itself and brings the static page to life. And the latest step in this evolution? Things like React server components, which try to be even smarter about shipping way less JavaScript to the client.
So while everyone was busy trying to solve performance, another problem was quietly brewing inside the code itself. As our teams and apps got bigger, our front-end codebases were becoming these massive, tangled, unmanageable monoliths.
Okay, so the first step to taming this monster was to just bring some order to the chaos. The modular monolith doesn't actually change how the app gets deployed, but it forces you to create strict boundaries inside the code between different domains like payments or user profiles. This makes the code so much easier to understand and work with.
But for those huge enterprise-scale apps with hundreds of developers, the next logical step was to just break the monolith apart completely. With micro front-ends, different teams can build, test, and deploy their little piece of the application all on their own, completely independently from everyone else.
Right, but here's the crucial point. While micro front-ends sound amazing for letting huge teams work in parallel, they bring an absolutely massive amount of complexity. For most projects, this is total, complete overkill. It will actually slow you down. It's really a pattern for huge scale, not your average everyday application.
So how do we take all of this history, all of these concepts, and use them to really articulate what we know? This is what separates a pretty good answer from a fantastic one in a senior engineering interview.
Before your next big interview, do this. Use this checklist and run an audit on your current project. Don't just think about what framework you're using. Think about the why. Why did we choose this? What trade-offs did we make? What problems do we have right now? This is how you start speaking about your work at a true architectural level.
You see, this is the difference. The junior answer is, we use React. But the senior answer, it sounds like this. It mentions specific patterns like static site generation or server-side rendering. But more than that, it shows a deep understanding of the entire system, its history, its trade-offs, and where it might go in the future. It proves that you think in systems, not just in code.
And now that you have this map, this whole history of how front-end architecture has evolved, the final question is really for you. Look at your own project, understand its trade-offs, and then ask yourself, based on our needs, our challenges, where do we go next? Because that right there, that's the kind of thinking that defines a senior engineer.